Hello, today we are going to learn about generator expressions in Python. A generator expression is a special way of generating values one at a time instead of creating and storing all values in memory at once. This is different from list comprehension, which produces all values at once and stores them in a list. Now, why would we want to generate values one at a time instead of all at once? Imagine you are working with a very large data set, such as millions of numbers. If you store all of them in a list, it takes up a lot of memory. But if you use a generator, the program produces values one by one only when needed, which saves memory and improves performance. Let's look at an example to understand this concept better. Suppose you want to calculate the sum of squares for numbers from 0 to 9. One way to do this is by using list comprehension, which stores all squared values before calculating the sum. In this case, Python first creates a list containing all squared values and then calculates the sum. However, there is a more efficient way to do this using a generator expression. Instead of storing all squared values, it generates each squared value one at a time and immediately sums it. This method significantly reduces memory usage. The key difference between these two approaches is that lists hold all values at once, while generators produce one value at a time and do not store them in memory. For small data sets, the difference may not be noticeable. However, when handling thousands or even millions of values, using generators makes a huge impact. They help reduce excessive memory usage, making programs run faster and more efficiently. Now let's see a practical example. First, let's create a generator that produces the cubes of numbers from 0 to 5. When you run this code, the generator will not compute all values at once. Instead, it will generate values only when we request them. To retrieve values from a generator, we use the next function. Calling next on the generator produces the next value in the sequence. Each time we call next, the generator moves to the next value and produces it. For example, when we call next the first time, the generator outputs 0. The second time, it outputs 1. The third time, it outputs 8. The generator continues until it has produced all values in its range. If we call next after all values have been produced, Python will raise an error because there are no more values left. Now, instead of calling next multiple times, we can use a loop to retrieve values from the generator more efficiently. For example, we can create a generator that produces cubes of numbers from 0 to 5 and use a loop to print all values. The loop will continue requesting values until the generator has produced all of them. Another useful example is creating a generator for squares of numbers from 0 to 9. Instead of storing all squares in memory, the generator produces them one by one. You can retrieve these values using a loop or by calling next repeatedly. To summarize, today we learned about generator expressions and how they help save memory by producing values one at a time instead of storing all values at once. We compared generator expressions with list comprehension and saw that generators are more efficient for handling large data sets. We also learned how to retrieve values using the next function and how to iterate through a generator using a loop. That concludes today's lesson on generator expressions. Thank you, and I will see you in the next session.